Okay, so now we're moving on to our next problem with some errors. So for this one, we had to look at a dot plot and we had to figure out the mean, the median, and the mean absolute deviation of this data set. Now, this data set's really simple. It's just 3 numbers because it's just remember, each dot represents how many times that number occurred in the data set. So we have 1 0, 1 3, and 1 6. Okay, so it looks like, but this person somehow got the mean of 4.5 or 4.5, median 4.5, and a MAD as 1. So let's look at what this person did. So this person went ahead and showed his or her work. So if we look here, it looks like this person decided to add 3 and 6 together, these two numbers as part of the data set, and divide it by 2 to get the median. And for the mode, looks like this person also did the same thing. I mean, not mode, for mean, I apologize. To find the mean, this person also divided it by 2 to get the mean. And the MAD, this person did find the distances between the mean and each number in the data set, but because this person already had the incorrect mean, it kind of threw off the mean absolute deviation. And also, if you notice, the 0 is not included in their data set. So this person whoever it is, added the numbers together and divided it by 2. Meaning this person did not include the 0, even though the 0 is still included as part of a data set. If the 0 is in a data set, you still have to include it. It's still a number in the data set. So this person was technically supposed to divide it by 3, not by 2. So let's correct it below, okay? So we have 0, 3, and 6. So let's just write what we have in our data set. Okay, already the numbers are put in order. It's really easy because it's only 3 numbers. So if we look for a median, the number in the middle, in the center, is 3. So that's our median. Just because the 0 is a 0, it's still included in the data set. So we have to have that as part of our data set. So it's still there. So we have to use it when we're trying to find the median and the mean. Okay, so now that we have our median, let's find our mean. So again, mean is the sum of data divided by the number of data. So 0 plus 3 plus 6 equals 9. But remember, we have to divide it by the number of data. How many numbers do we have in our data? Hopefully you thought in your head we have 3, because you can't, even though the 0 is a 0, it doesn't have any value to it technically, it's still part of the data set, so we have to include it as a number in the number of data. So 9 divided by 3 equals 3. Okay, so the mean is also 3. So our median is 3 and the mean is 3. Okay, so now to find the mean absolute deviation, it's only 3 numbers, so it's not as tedious. So now that we have our mean, we have to find the distance between the mean and each number in the data set. So I'll write down each number in our data set. Okay, and then the distance between 0 and 3, or basically 3 minus 0, which equals 3. 3 to 3, the distance between 3 and 3. How many jumps does it take to get from 3 to 3? None, because you're already at 3. Or you can think of it as 3 minus 3 will equal 0. Now what's the distance between 6 and 3? How many jumps does it take to get from 6 to 3? Or another way to think of it is 6 minus 3, which equals 3. Okay? Then we have to find the mean of these distances. So 3 plus 3 plus 0 equals 6. Then we have to divide that by the number of values in the data set, and there are 3. Remember, always include that 0. 6 divided by 3 is 2. So the mean absolute deviation is 2. Okay? So if we look back, when we made this correction, we look back and we think, okay, so what did this person do incorrectly? Well, it looks like this person was on the right track, because even though, especially, and here's the thing about median, and I need you all to remember this. You're not always going to need to add the two numbers together and divide it by 2 to get a median. You only do that if there's 2 numbers in the center. For this data set, there's 3 numbers, so we have 1 number in the center, and it's 3. So we don't have 2 numbers. So we don't always have to add 2 numbers together and divide it by 2 to get a median. You only do that if there's 2 numbers in the center, or if you have an even amount of numbers. So if there was like another number here and there was 4, then we would have 2 numbers in the middle. Then that's when we would have to add it and divide it by 2. But because we do not, we just have the number in the middle. That's our median. That's all we had to do. And then for mean, this looks like the person didn't divide it, did not include 0 in their data set, because this person probably thought, okay, well, it's 0. It doesn't need to be included in the data set. So, and that's okay. That's a common mistake. And remember, these errors are common mistakes that happen with a lot of students. And that's why we're going through this error analysis. So we have to include 0 in the number of in the data in general. So we can't just divide it by 2. We have to divide it by 3, because there are 3 numbers in our data set, even if one of them is 0. Okay, and that's how we get our mean. And also, once we have our correct mean and we have our correct median, we're able to get the correct MAD, because then we can find the correct distances from the numbers in the data set. Ooh, I'm getting tongue-tied. The numbers in the data set, we can find the distances between the numbers in the data set and the mean. And then once we find the distances, we can add them together and divide it by however many there are. Basically finding the mean of the distances. And that's how we get our answer. So based on what you saw here, what do you think this kind of error is? Do you think it's a computational error, a careless error, or conceptual error? Think about it a little bit. Okay, so I think that it's a conceptual error, because it looks like this person just didn't realize that the 0 had to be included in the mean. And also I think this person also forgot that if there's an odd set of numbers, the median is easy to find because it's just the one number that's in the middle, not necessarily always having to add the 2 numbers and divide it by 2. Please remember that when you're finding the median of a data set, if the median, so I'm going to write this down because this is really important. So, median. If the data set is even, you're going to have to find the mean of the 2 middle numbers. Now, if the median, if the data set is odd, so if there's 3 numbers in the data set or just 5 numbers in the data set, you just have to find the center number. That's it. That's all you need to do. It's only when the data set is even. So if you have 4 numbers in a data set, or if you have 6 numbers in a data set, you're going to end up with 2 numbers in the middle. That's when you have to add them and divide it by 2. Okay? I cannot stress that enough, because it is a common mistake that I keep seeing. Okay. All right. Let's go ahead and move on to the next page. Okay, so this one's a pretty easy one. This one, we just had to analyze a dot plot, and it says the gas mileage for each car at Miley's Motors. Okay, so we are looking at a dot plot where it shows how each car and each car here is represented and shows how much gas mileage each car has. Okay, so this person, it looks like this person was on the right track. This person said state where there is a gap in the data, and I completely agree. Between 16 and 19, there's a gap there. We have 33 and 37. There is a gap there. There's space there. Okay, what is the peak And remember, again, the peak is the highest point, or where the data is highest, and that's at 25 miles per gallon. So it's at the 25 right here. And this person is correct, and even put largest peak here. Now, when it gets to this part, how many cars are included in this data? Okay, so this is where I saw a couple of people had, it looked like it had the two same numbers that were popping up a lot. Okay, it is not 18 cars. If you look here, it says the gas mileage, hold on, let me look at my notes here. The gas mileage for each car. Okay, for each car. So let's try to make a correction right here. So let's look at this. So this is the data set, right? This is our dot plot. So the gas mileage for each car at Miley's Motors. So each dot represents a car. Okay, because it says so right here. It's the gas mileage for each car at Miley's Motors, and this is the miles per gallon that each car has. So each dot represents a car. So it looks like this person got 18 cars because this person just counted how many columns were represented in the dot plot. And there are in fact 18 columns in the dot plot, but that's not the thing you're supposed to count. You're supposed to count how many dots are in this dot plot. Because again, if I'm asking how many cars are included in this data, each dot represents a car. So make sure when you're analyzing a dot plot, you need to look at the title, look at the x-axis, look at all the information given to make sure you're analyzing the dot plot correctly. So if you count all of these dots, there are in fact 75 cars represented in this data. Okay, now check for yourself. Do you think this is a computational error? Do you think this is a careless error? Or do you think this is a conceptual error? Now, personally, I think it could possibly be all three of these things, or it could be, I'm leaning more towards the conceptual error because it looks like this person wasn't sure what to count in the dot plot. So this person counted the columns, thinking that each column represented a car, but in fact it's the dots that represent the car. Okay, so I believe it's a conceptual error. Maybe it could be a careless error. Maybe this person was not going through the data, did not read the data carefully. So maybe it could be both. It could be conceptual and it could be careless because maybe this person did not read all of the information carefully and then go over it carefully. So it might have just been a careless error. Okay.